Okay, this is an obstacle avoidance car, and let's see how many obstacles this car can avoid. Okay, let's start this car. So from the intro, you just saw that we are going to make the obstacle avoidance car in this video. So here's the thing, will it not hit any of the walls, or if we add multiple sensors, this will work maybe better. So watch this video and make this car to know the science behind it, and also how can we improve this car more with adding some more sensors here. So at first, let's have the components breakdown here, what we have used to make this obstacle avoidance car. So at first, you just need this 4WD chassis with 4 TT motors. And then I have used 3.7 lithium ion batteries, and this is the 3 batteries which make up to 11.1 voltage here. And a switch, and L298N motor driver, and here this is the Arduino Nano with connected in the expansion board, and this is just SG90 servo motor, and this is the ultrasonic sound sensor, and you can just 3D print this component, this part, to mount this in the SG90 servo motor. So now let's break down how for 4WD chases we can use the L298N motor driver and connect these 4 motors, because the L298N has 4 terminals where you can just put the 4 wires, but here 4 TD motors and total up to 8 wires have to connect. So let's see how we can do this. So here you can see 2 motors connected with the tire. Let's assume these are this side motors, the left side's motor, and they're placed in the opposite direction of each other. They're not like parallel in this direction, they're just placed like here. So just wear them with the different colors, like first make them parallel and make it white, and also make it white, make it another color, make it another color of the same size motor. So when you just reverse this, you just make a twisted pair with this brown and the white color, the opposite colors. Take these two together, just twist them and make a terminal, and the other two, take them and make another terminal. So this 4 sums up to 2 terminals, and just place them in the output terminal of this side and consecutively for the other side. So after that, in the battery pack, this is 11.1 voltage. Just connect to the positive terminal or the 12 volt terminal of this L298 motor driver, and here's the 5 volt terminal. Just connect with the Arduino, and that's it. And the negative terminal of this battery, connect this to the ground, and take a ground from this Arduino and connect this. Make a common ground like this one. Here I have used a common ground, one terminal to Arduino and another terminal connected to this battery pack. And also don't forget to use a switch here in front of the board. And here your servo motor is working, and the HCS servo 4 is also working. So now how to wear this HCS servo 4 or the ultrasonic sound sensor with the servo motor. You can place like dual-sided tape in the front and just place the servo motor, or you can use the hot glue gun, and on top of that you just use the servo motor connection that comes with the servo motor. Let me show you an example, just like this one. Place in the top and add glue gun with the mount of this ultrasonic sound sensor, and just place here and make a nut bolt connection. So now let me go through the L298N and the Arduino connection. So this is just very simple. I didn't have used any enable pin A and enable pin 2B, but you can use them. I have just simplified this by not using them, but if you want the speed control, you can use the enable A and enable B. And the other terminals are connected to the Arduino shield. So I will also have the wiring of this motor controller, Arduino shield, servo motor, and the ultrasonic sound sensor in the blog that I made about this obstacle avoidance car. So just check this out from the description and have the complete wiring done. So you have completed the wiring from the website I just linked, and now we are ready to go about the coding. So first of all, let me give you a practical example of how this works. In the front, if this sensor detects no obstacle, it just goes to the front. And when, suppose that here is the obstacle, suppose that there is this type of an obstacle, so the sensor detects it and stops the car. And when it stops the car, it scans to the left first, then again scans to the right. and then centerize this. So here's another barrier, and on the left side this is the empty space. So suppose that this is the barrier, so it will measure the distance, the left distance and the right distance. And when it detects that the left distance is bigger and the right distance is shorter, the car will rotate to the left and just start going to the forward. And that's how this works. And for better case, we have just used a backward movement, a little bit of backward movement, so it will have more space to move. Suppose that the car goes front and front again and just faces an obstacle, the car just goes a little bit backward and then does the scan thing. So right now, let's walk through this coding part of this obstacle avoidance car. So in the first, you can see the constant integer definition for the input pin of the servo motors. These are in1, in2, in3, and in4. Then the servo pin and trig and echo pin. So trig pin and echo pin are for this ultrasonic sound sensor. Since you know that ultrasonic sound sensor triggers a sound wave and then receives with the echo pin. So here the safe distance, I have used 35 centimeters, but you have to calibrate according to your robot size and the sensors or the battery you are using for this motor controller. So then the backward duration, I mean after facing an obstacle, how long will it move backwards? So this is 150 milliseconds, and all the units are in the milliseconds. Then turn duration is 280 millisecond. I mean, detecting an obstacle, it will just move left or right with how many seconds. And then scan delay, like it will rotate to a direction, then scan duration, then rotate to the another direction, and then the scan duration. And for the left angle, this is 180. For the right, this is 0. So let me show you how I just placed the servo motor for your better understanding. So the motor side is in the backward of this motor housing. So and then the complete setup is very simple, and the loop where we are getting the distance and checking if it is smaller than the safe distance or greater than the safe distance. And then the functions for moving forward, moving backward, turning left, turning right, and stop the car. And this is the get distance, and we are getting the distance using this ultrasonic sound sensor. And then the obstacle avoidance mode, here you can see the left distance. Scanning this angle, we are having the left distance and the right distance. So here there's two delays. You can see this is 500. So at first this is just centerized, right? Then rotate to the left distance with 500 millisecond, and then to the right with 500 milliseconds, and then centerized with 300 milliseconds duration. And then it just checks the left distance is greater than the right distance or not, and just rotating the car in the corresponding directions. So yeah, this was the complete coding. Just connect to your Nano and upload this code. Let's see how many obstacles this car can avoid. Okay, let's start this car. Okay, it hasn't hit any of the obstacles still. Okay, let's see if this can avoid this camera or not. Okay, this avoided this camera. Okay, first obstacle hit. So let me give you the reason for this bump you just saw there happen. This happened because the car was moving like an angle, and when this moves like an angle, this ultrasonic sound sensor fails to detect the obstacle. You can reduce this using 3 ultrasonic sound sensor, like making a 45-degree angle here and another here, and reducing the servo motor. By this way, you can improve this car. So I think you had fun making this very beginner friendly project in this channel. So you can do various types of modifications, like you can add 3 HCSRO ultrasonic sound sensors in the front, and you can reduce the servo motor, and you can use the PWM control, also connect the Bluetooth module for making it an RC car plus obstacle avoidance car. So just let me know in the comment section what modifications you just want in this car and make it your car. So thank you very much for watching. Stay tuned with Robotics and subscribe to this channel. Thank you very much.